Measuring gravity at the surface of the Earth. Introduction. Gravity is one of the most fundamental forces in nature. It's what keeps us grounded on Earth and governs the motion of planets, stars, and galaxies. But have you ever wondered how scientists measure the acceleration due to gravity at the Earth's surface? In this video, we'll explore a simple yet effective method to measure gravity using everyday objects and basic physics principles. By the end, you'll not only understand how gravity is measured but also be able to try this experiment yourself. Let's dive in. Chapter 1. What is gravity? Before we measure gravity, let's understand what it is. Gravity is the force that attracts two objects with mass toward each other. On Earth, gravity gives weight to objects and causes them to fall toward the ground when dropped. The acceleration due to gravity, denoted by the letter g, is approximately 9.8 meters per second squared near the Earth's surface. This means that every second an object falls, its speed increases by 9.8 meters per second. Gravity isn't just important for keeping us grounded, it plays a crucial role in everything from the motion of celestial bodies to the functioning of satellites and even the flow of water in rivers. Measuring gravity accurately helps scientists understand the Earth's structure, predict tides, and even explore other planets. Chapter 2. The experiment, dropping an object. One of the simplest ways to measure gravity is by dropping an object from a known height and measuring the time it takes to hit the ground. Here's how it works. 1. Drop an object. Choose a small, dense object like a metal ball or a rock. This ensures that air resistance has a minimal effect on its fall. 2. Measure the height. Use a measuring tape or ruler to determine the height from which the object is dropped. Let's call this height d. 3. Time the fall. Use a stopwatch or a smartphone app to measure the time it takes for the object to hit the ground. Let's call this time t. Once you have these two measurements, you can use a simple physics formula to calculate the acceleration due to gravity. Chapter 3. The physics behind the experiment. The motion of a falling object can be described by the equation. Distance equals 0.5 times gravity times time squared. Or, in symbols, d equals 0.5 times g times t squared. Here's what each term means. D, the distance the object falls, height. G, the acceleration due to gravity, what we're trying to find. T, the time it takes for the object to hit the ground. To solve for g, we rearrange the equation. G equals 2 times d divided by t squared. This formula tells us that gravity is proportional to the height from which the object is dropped and inversely proportional to the square of the time it takes to fall. Let's break this down further. Chapter 4. Step-by-step calculation. Let's say you drop an object from a height of 10 meters and it takes 1.43 seconds to hit the ground. Here's how you'd calculate g. 1. Square the time. T squared equals 1.43 times 1.43 equals 2.04 seconds squared. 2. Plug the values into the formula. G equals 2 times 10 divided by 2.04. 3. Calculate the result. G equals 20 divided by 2.04 approximately equals 9.8 meters per second squared. This result matches the accepted value of gravity on Earth, which is approximately 9.8 meters per second squared. Chapter 5. Why this method works. This method works because it relies on the fundamental principles of kinematics, the branch of physics that deals with motion. When an object is dropped, it accelerates downward due to gravity. Assuming air resistance is negligible, the only force acting on the object is gravity, making the calculation straightforward. The equation d equals 0.5 times g times t squared comes from integrating the acceleration due to gravity over time. It assumes that the object starts from rest, initial velocity is 0, and that air resistance is minimal. For small heights and dense objects, these assumptions hold true, making this method both simple and accurate. Chapter 6. Factors that affect the experiment. While this experiment is simple, there are a few factors that can affect the accuracy of your measurement. 1. Air resistance. If the object is too light or has a large surface area, air resistance can slow it down, leading to an inaccurate measurement of g. To minimize this, use a small, dense object like a metal ball. 2. Human error. Timing the fall manually can introduce errors. Using a digital timer or a smartphone app can improve accuracy. 3. Height measurement. Ensure the height is measured accurately. A small error in height can lead to a significant error in the calculated value of g. 4. Initial velocity. The object should be dropped from rest. If it's given an initial push, the calculation will be incorrect. By controlling these factors, you can improve the accuracy of your experiment. Chapter 7. Real-world applications. Measuring gravity isn't just a classroom experiment, it has real-world applications. 1. Geophysics. Scientists use precise measurements of gravity to study the Earth's interior. Variations in gravity can indicate the presence of minerals, oil, or even underground water. 2. Space exploration. Understanding gravity is crucial for launching satellites and spacecraft. Accurate measurements help engineers design trajectories and ensure missions succeed. 3. Engineering. Gravity measurements are used in construction to ensure buildings and bridges can withstand the forces acting on them. 4. Climate science. Changes in gravity over time can provide insights into melting ice sheets and rising sea levels. This simple experiment is a gateway to understanding these complex applications. Chapter 8. Historical context. Of gravity has a rich history. Sir Isaac Newton was the first to mathematically describe gravity in his law of universal gravitation. Later, Albert Einstein revolutionized our understanding with his theory of general relativity, which describes gravity as the curvature of spacetime. The experiment we're discussing today is rooted in Newton's laws of motion. It's a testament to how simple observations can lead to profound scientific discoveries. By dropping objects and measuring their fall, we're following in the footsteps of some of the greatest minds in history. Chapter 9. Variations of the experiment. While dropping an object is the simplest way to measure gravity, there are other methods you can try. 1. Using a pendulum. The period of a pendulum, the time it takes to swing back and forth, depends on gravity. By measuring the period and the length of the pendulum, you can calculate g. 2. Free fall apparatus. Advanced setups use electronic sensors to measure the time of fall more accurately. 3. Laser interferometry. In laboratories, scientists use lasers to measure tiny changes in distance caused by gravity. These methods offer greater precision but require more sophisticated equipment. Chapter 10. Why measure gravity? You might wonder why measuring gravity is important. Here are a few reasons. 1. Understanding the Earth. Gravity measurements help scientists map the Earth's interior and study tectonic plates. 2. Predicting natural disasters. Changes in gravity can indicate volcanic activity or earthquakes. 3. Exploring other planets. Measuring gravity on other planets helps us understand their composition and whether they could support life. 4. Everyday applications. From designing roller coasters to calibrating scales, gravity measurements are used in many industries. Gravity is everywhere, and understanding it helps us make sense of the world around us. Chapter 11. Try it yourself. Now that you understand the theory, why not try this experiment yourself? Here's what you'll need. A small, dense object, like a metal ball or a rock. A measuring tape or ruler. A stopwatch or smartphone app. A safe place to drop the object, indoors or outdoors. Follow these steps. 1. Measure the height from which you'll drop the object. 2. Drop the object and time its fall. 3. Use the formula G equals 2 times d divided by t squared to calculate gravity. 4. Compare your result to the accepted value of 9.8 meters per second squared. This is a fun and educational activity that you can do at home or in the classroom. Chapter 12. Common mistakes to avoid. When conducting this experiment, watch out for these common mistakes. 1. Inaccurate timing. Start the timer the moment the object is released and stop it the moment it hits the ground. 2. Incorrect height measurement. Measure the height from the bottom of the object to the ground. 3. Air resistance. Use a small, dense object to minimize the effects of air resistance. 4. Dropping the object incorrectly. Ensure the object is dropped from rest, don't give it an initial push. By avoiding these mistakes, you'll get a more accurate result. Conclusion. Measuring gravity at the Earth's surface is a simple yet powerful experiment that demonstrates the principles of physics in action. By dropping an object and timing its fall, you can calculate the acceleration due to gravity and gain a deeper appreciation for the forces that shape our world. Whether you're a student, a teacher, or just a curious mind, this experiment is a great way to explore the wonders of science. So grab an object, measure its fall, and discover the power of gravity for yourself. Thanks for watching, and happy experimenting.